Hi everyone, welcome back to Art of the Part. In this video we're going to continue on with our bracket exercise P1 and program second operation in MasterCam. In the last video we took a look at first operation, and it's going to be all of this toolpath that you see here, and it's going to be located underneath toolpath group 1. So if I select this toolpath group and I run this and verify, I'm going to speed this up so you can see what the final result is. But when I hit play, you can see that we did a series of roughing and finishing toolpaths, and we even did this inside pocket as well as some drilling details. So this is going to be the final result if you ran this first operation on the machine, and we basically want to take this result and use it as reference for second operation so we can use that as our stock model. Because all we need to do is flip this around and then remove this material on the back side so that we can mill this flat. So I'm going to back out of verify, and we're going to take a look at creating a stock model to be used as reference in the second operation. So the first thing that we want to do is create a new toolpath group for that second operation. So this is going to be very important, but up here in the top left hand corner in our operations manager, you want to select the current machine group. So we're going to select machine group, and then we're going to right click on that machine group, and from this drop down menu we're going to find the group selection, and then inside that group option here we're going to select a new toolpath group. And again, this is very important. You don't want to accidentally click on new machine group because that's going to create a new machine, and you'll have to reset up your tool library as well as your stock material. So we want that all to be linked together, especially going from first operation to second operation. So you're going to select the new toolpath group. So you can see here in the operations manager we've created this new toolpath group, and if you wanted to keep organized here you can just name this second op. And we can go ahead and rename the first op as well. So toolpath group 1, we click on it once, wait 1 second, click on it again, and this is going to allow us to rename this, and I'll name this first op. So we can clearly see what's first op and second op. We have separated them, so if you click on first or second op you can verify them independently as well as post the G code independently as well. So let's go ahead and click on the second operation, and we're going to be inside of that toolpath group now, and we're going to go ahead and create that new stock material from reference from the first operation to be used as a stock material for second op. So what we want to do is make sure that we're here inside of the toolpath tab. Inside the toolpath tab you're going to locate the stock section, and we're going to click on stock model. So click on stock model. It's this half pipe looking icon. It's in gray. So if you click on stock model here, this is going to open up the new stock model window. So we want to make sure that we're naming this, so I'll just say that this is going to be first op finish. And you can go ahead and change the color of this stock model to whatever you want, but there's going to be this little color palette here. If you click on that, this is going to open up all of your different colors. I'll go ahead and make mine pink. I like nice and bright colors. It's easier to see the toolpath project against that, and then we'll hit the green check mark. So again, this is why it's important to make sure that your toolpath groups are in the same machine group, because we want to just be able to click on stock setup and it's going to recognize the stock material that you have previously set up for first operation. So go ahead and click on stock setup. It's going to recognize the X, Y, and Z extents there, and that's going to be used as reference as we project toolpath against it. So over here on the top left, right underneath stock definition, we're going to go to source operations. So click on source operations, and now we're just going to choose what toolpaths we want to project against the stock material. So this should be pretty easy. All we want to do is just select our entire first operation. So if you click first op, it's going to highlight or select all these 9 toolpaths, and then we'll hit the green check mark, and this will take a second to regenerate, but it's going to project all that toolpath and create this mesh file, basically what you saw at the end of our verify from first operation. So now that we have our stock model as reference for second op, let's go ahead and toggle this toolpath off, because I want to be able to access the backside as we're creating some new planes. So this stock model is going to operate a lot like toolpath geometry because it is toolpath geometry, and in the top left hand corner underneath toolpaths we can actually toggle this on or off by clicking on the 4 little waves here. So we'll click on toggle this on or off. So again, we can toggle that on or off. I'm going to keep it off, and we basically want to rotate the part around to the back side, and we want to create a new plane so that this face or this side is going to be our new second op top. So just like what we did before, we're going to follow the same exact workflow. We're going to move down here to the bottom ribbon of tabs, and we're going to go to the Planes tab. So click on Planes. And then inside the plane tab, we're going to create a new plane by going up here to the top left-hand corner. We'll click on the green plus button. And when we click on that green plus button, we're going to go down in this drop-down menu and find Dynamic. So click on Dynamic. This is going to link a gnomon to your mouse. And we're just going to relink this gnomon here to the back edge or the back face of the part. And we're just going to center it on this half-inch hole. So I'm going to click on this outside edge here of this hole. We'll click on that once. And instead of doing multiple rotations, if we're looking at the three-finger rule, Z is pointing down, we would have to essentially flip this around and then rotate it again so that X and Y are pointing in the right direction. The easy way to do this is we're just going to do one single 180 flip so that we rotate around the Y-axis. Because if we're looking at the three-finger rule, Y is pointing this way, Z is pointing this way, and X is pointing that way. Instead of doing multiple rotations, we'll just go ahead and rotate around Y so that Z is facing up and then X is in the correct orientation. So again, we're going to look at the Y stem. That's going to be the green stem there, and we can click on any one of these green segments to rotate around in Y. So I'll click on this green segment there. Again, I'll just make note of this. We don't want to accidentally click outside of the compass because that's going to place you wherever your mouse is. So that's like 17.46, 41.26, so on and so forth. So we just want to rotate inside the compass. This is going to be 5-degree increments, and we're going to go to 180 degrees. And again, you can imagine this with the three-finger rule. We're effectively just rotating around Y. This is going to be a B rotation so that Z is pointing up. So we'll click here. We're going to that 180 degrees, and then we're going to title this new plane as second op top. And then we'll hit the green check mark. And again, if we right click in the viewport and we try to go to the top plane, we're still currently linked to the first op top. So we have to relink this all, the WCS, the C, and the T, to the new second op top plane that we just created. So I'll click on the WCS, I'll click on C and T, again, working coordinate system, construction plane, tool plane. So if we right click out here in the viewport and then from the drop down menu I go to top, now we're looking head on to the back side of the part, which is going to be second operation. Okay, so we've already created our stock material and we've created this new plane here. So let's move over to the levels, because as we start to get into multi-op programming, especially when we're doing 5-axis programming, we want to start to import our work holding so that we know where everything is inside the machine so that we don't accidentally crash our tool into a certain location or into those jaws or into the table. So we're going to click on the levels here and we're going to create a new level for our work holding assembly. So up here in the top left hand corner of the levels tab, we'll click on the plus button. This is going to create one new level for us. We'll double click on this level right here and we'll just name this a work holding level. So we'll just name that work holding, hit enter to apply that name change, and then we currently have 0 entities linked to that work holding level. So what we want to do here is actually bring in the work holding assembly that we created in SolidWorks with the soft jaws so that we can see how all of that reacts with our toolpath. So we're going to go up here to the File tab, or sorry, the File option up here in the top left-hand corner. We'll click on File. And from this drop-down menu, instead of going and opening up a new assembly or a new part like we've done before, we're actually going to start to use what's called the Merge command. So if we click on Merge, this is going to be almost like an insert components like we would do inside of SolidWorks, especially for assemblies. And if you have access to the Google Drive and you're in class, you should be able to download this Vice and Riser with Soft Jaws folder. But I'm just going to open that up, and you might have to toggle this so that you can look for all files. It might be looking for just MasterCam files right now, so just make sure that you're on all files. And we're going to look for this SolidWorks assembly for the 5-axis Vice and Riser, Soft Jaw A-4. It's whatever you created for the soft jaws for the bracket exercise components. So we'll click on the 5-axis Vice and Riser right here, and then we'll click on Open. And this is going to be very important. There's a couple clicks that we have to do in a specific order for this to apply the correct way. The first thing that we want to do is we can see that this assembly has been brought out here into the viewport, but we want to make sure that we are linking this to the current active level. If you just select merged file levels or offset by levels, you're going to create multiple different levels and all these components are going to be separated. I think in my experience, it's just best to have all of your work holding on one single level. That's why we created that work holding level in the last step here. So please make sure that you have active levels selected. the next thing that we want to do is we want to move this model out, or move this assembly out of our model right now, because it's currently overlapping. And that's not like MasterCam isn't doing this in the wrong way. It's just trying to link the origin of that assembly to the origin of the MasterCam file. So we just need to move this out of the way, and we're just going to rotate it and then put it in place so that it can be used for second operation here. So the easiest way to move files, especially when you're inside the merge pattern command, is just to click on dynamic right here. So if you click on dynamic, this is going to allow us to move and rotate this part dynamically without having to go through multiple different steps. So right now, everything that we brought in is highlighted in red. That is going to be that merge assembly component that we just brought in. And we're just going to rotate this around, or move it around from this center hole on the back side. So you can click on the outside edge of the center hole right here. We'll click on that once. And then you can pull and drag on any one of these axes. So for example, if I want to move this in Z, I'm just going to click on this blue stem, or this blue axis. We'll click on that once. And then you can see that I can move it up or down. So I'm just going to move this all the way up here, and then we'll be able to see this a little bit easier. So right now, we basically want to put this part, or this component, in the center of these soft jaws. However, we don't want to link this so that this side is facing up, because we just completed that. That is the complete first operation. So all we would be doing is taking first operation and then putting it in a new set of soft jaws. Likewise, we wouldn't even be able to set that in there because we have that big rectangle, or the leftover stock material from first operation, on the back side. So we effectively need to take this entire work holding assembly and then rotate it around 180 degrees so that the first operation is being held inside of the soft jaw. So we want this face to be held on this face. So just like what we talked about before when we created that new plane, we don't have to go through multiple rotations. For us, I think it's going to be very easy to just rotate around the y-axis, and that way the work holding assembly is going to be flipped around 180 degrees. So let's go ahead and just zoom in here to this gnomon, and we can go ahead and click on any one of these green stem segments. So we'll click on one of those green segments, and again, we're just going to rotate this around 180 degrees. I'm just going to move this so I can see it a little bit easier. 180 degrees so that Z is facing up. So we're going to click there at 180 degrees. We'll click on the green check mark. And then we're just going to dynamically move this one last time. So we basically have to take this and move this edge right here so that it's in line or collinear with this edge back here. So this can be a little bit tricky, and I think the easiest way to do this is, again, we'll select on the dynamic command, and we're just going to rotate this around, and we're going to zoom in to this edge, and if we click on this edge here, we're going to move this entire work holding assembly dynamically from that edge. So we'll click on that edge right there, and we're going to click on the gray ball in the center of these gnomons. So we're going to go ahead and click on this gray ball here. When your mouse is hovering over it, it's actually going to highlight in yellow. So we'll click on that once, and I'm just going to zoom out here, and then I'm going to zoom into my component. And this is where things get a little bit tricky, because you effectively need to memorize where this line is at so that it links into place in the correct fashion. Now, if you're not able to do that, and I totally understand it's a very difficult task to do, you can actually come up here to the View tab. So we're going to click on View in this top ribbon here, and you can select translucency so that we can see we can see transparently through the part, and we can actually click on that edge a little bit easier. So again, we're inside this View tab. We're going to click on translucency, click on that. You can actually see through the entire component, or both components here. And as I said, it might be a little bit easier here to actually zoom in and link this edge to this edge from the bracket exercise. So we'll be able to click on that edge right there. and then we can actually change this back or toggle it back to the solid model. So if you go ahead and click on translucency once again, that's going to turn off that transparent view, and then we'll go ahead and hit the green check mark. And then if we want to apply all these movements, we're just going to hit the green check mark one last time. So we'll click on this green check mark one last time, and you can see that we've moved or imported this new work holding assembly all to this work holding level. And this is like a little error that I've been seeing in the newer versions or the newer educational versions inside of MasterCam, where it actually does create a separate level for each one of these components, but it doesn't place those components on those separate levels. So you can see on this work holding level that we created, we linked it to the active level. We currently have 7 entities linked to that work holding level. So if I want to get rid of these empty levels, to me it's just a lot of wasted space. I'm just going to click on this 4th level here. I'll hold down the shift key, and then I'll click on the 9th level so all of them get selected, and then I'll right click on one of them, and then from the drop down menu here I'm just going to clear empty levels. So if you clear empty levels, we're going to do selected. It'll get rid of all of those extra levels. Again, I think it's just a glitch that happens in the newer versions or the newer educational versions of MasterCam when you're bringing in assemblies from SolidWorks here. So we currently have this new work holding assembly on this work holding level here. Again, we have 7 components. If you want to be able to toggle this on or off, especially if you are approaching this from multiple different sides, if you're indexing or doing 5-axis simultaneous programming, all you need to do is change your check mark, and I'm just going to put this here on the first level, which is going to be the bracket exercise P1, and you can actually hit this X button inside the levels tab to turn off your work holding or turn it back on. So we're going to keep that work holding on. This is going to be very helpful for us, especially as we're going through these next couple of toolpaths. But we're just going to move over here into the toolpaths tab. And again, we're going to be working here in this second operation. So this should be relatively simple. If I toggle this toolpath on for the stock model that we created, we can see that we're just trying to remove this little bit of material, which should be easy enough to do with a face milling operation. So I'm just going to move over here into the toolpaths tab. So I'll click on toolpaths. Inside the toolpaths tab, we're going to click on the face mill inside the 2D gallery. So we'll click on face mill. And just like what we've done before, we want to be able to select on the wireframe geometry that we created for the stock model. So I need to toggle this from solid chaining to wireframe chaining. So we'll click on this wireframe icon right there. And then we'll just select this like we've done before. So I'll click on this top face there, or that top edge. And if I want to select the entire loop of that edge, I'm just going to click on the red fast forward play button here. So I'll click it 3 times. 1, 2, 3. You can see that I've selected that entire top edge there. We'll hit the green check mark. And then we can just jump down here into the tool tab. And then we can select the 3-inch face mill. So we'll do 3-inch face mill. And then we'll jump down here into the cut parameters. As we talked about before, we definitely want to make sure that we have auto angle turned on. If we have this turned off, it's going to try to go left to right, and we're not going to be able to project this tool path because the length of the material is wider than the diameter of the tool. So we're going to turn on auto angle so that we can go up and down, basically traveling in Y. And then we'll jump down here into depth cuts. This should remember all of the same settings that we've been using before. So we're going to use that 60 thousandths depth of cut, and we do want to make sure that the tool is kept down so that we're not retracting out every time that we make a tool pass. So we're going to go down here to linking parameters. As always, we want to make sure that we are registering absolute, 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 and absolute. Top of stock, we'll click on that. That should be the 3/16 that's currently active, but we'll click on one of these top corners here. And then we'll also click on this depth. And when we click on depth, we want to link it to the top edge or the top face of the back side of the part here. So we'll click on that edge right there, and we should get a registered value of 0. If you're not getting this registered value of 0, it's probably because you did not change your WCS, your C, and your T to the second up top plane. And a good way that we can check that is if we just jump down here into the planes tab. Inside of planes, you can see that the working coordinate system, the tool plane, and then the construction plane, they're all linked to second up top, second up top, second up top. If you see first up top in any one of these selections, you can go ahead and click on this select WCS plane, and then you can update this, and then you can copy that over using these fast forward buttons, or just click on that selection in each one of these separate columns here. So now that we have all the parameters set up, we have the planes in the correct order here, we can hit the green check mark and see how this toolpath gets regenerated. So I'll hit OK, and we can see that we are creating this face mill going up and down here in Y. And let's see what this all looks like inside of Verify after we created this stock model, as well as bringing in the work holding assembly here for the soft jaws. So I'll go ahead and select on the entire second operation so that all of these two toolpaths are selected, and then we'll go ahead and click on the Verify Selected Operations. So click on Verify Selected Operations right there. This is going to open this up here. And right now we currently can't see the work holding assembly that we brought in, and this can get a little bit confusing, but when we brought that assembly in, it's still registering that as the work piece inside the MasterCam. So if you click on work piece here, you can see this entire assembly, and that's not really what we want to see. We want to be able to toggle our entire work holding assembly here by using the fixtures. So if I click on fixtures, I can turn it on or off, and we also want to be able to generate a collision report if we are going to hit the fixture. So right now the work piece, this is all well and good, but we want to remove the work holding assembly from the workpiece, and we only want the finished or the final 3D model for the bracket exercise linked to the workpiece level. So if I play this out, we can see that the face mill operated the way that we want it to. However, I do want to relink this fixture level so that we will be able to turn it on and off and generate those collision reports. So I'm going to hit the X button here from the top right hand corner inside of our Verify window. And this is relatively easy, so as long as we imported this fixture assembly for the soft jaws and we linked it to a single level, all we really need to do is come back up here to our machine group, and we have to go back into the stock setup to enter into our machine group. So if you go ahead and click on stock setup, this is going to bring you back into your machine group setup. And you may have not noticed this before, but on the left hand side there's a handful of icons that we can toggle through for machine setup, and if you leave your mouse over one of those icons, it'll expand out, and what we're looking for right now is the fourth selection, which is going to be work holding. So if you click on work holding here, this is going to bring you into the work holding selection section, and we just want to activate fixtures. So this is going to link itself back into Verify when we try to toggle on fixtures. So we're going to click on fixtures right here, and again, this is why it was important that we imported or merged this entire work holding assembly to one single level, because right now there's nothing selected for the fixtures. But if you move down here to the selection of icons, we can go ahead and click on the first icon. We're going to add from level, so we'll click add from level. This is going to open up a new window for you. And like I said before, as long as you brought in that entire work holding assembly to a single work holding level, we can click on that and it's going to select all of those components on that one level. So if you had multiple different levels, so I think we brought in 7 different levels, and you had each one of those components on a separate level, you would have to select each one of those one by one, or hold down the shift key and select all of them so that they are all considered. However, we are just going to select on the work holding level, and then we'll hit the green check mark, and then we'll hit the green check mark one last time here. And now when we go back into Verify and I click on second op, and now I have both of those toolpaths selected, and we go to Verify, we will be able to see that the entire work holding assembly is going to be linked to the fixture level. So now if I want to toggle the fixtures on and off, so if I turn this on or off, you can see that we can manipulate that fixture geometry there. So let's go ahead and play this out. Again, this looks pretty good. However, as we start to get into more advanced programming, like 5-axis programming, especially for simultaneous and indexing, as well as we move into the third revision, which is going to be the bracket exercise P3, we are going to get a little bit closer here to the soft jaws. And you want to make sure that you aren't going to collide or intersect or cut into those soft jaws, especially when you have hard jaws, because hard jaws are quite expensive. So the hard jaws on our machine are roughly around $3,000. So it would be an absolute tragedy if we ran our tool into those and had to purchase those over again. We have a little bit more forgiveness with these soft jaws because I can go ahead and just machine a new set of soft jaws, but we never want to get into a habit of hitting our jaws or hitting any of our work holding components. So I want to show you why this is important, the way that we're setting this up. So if I backed out of verify here and I created a new toolpath, let's say I had to go and clean up the outside edge, there was maybe some flashing or there was some burrs that we had to remove, and I just went ahead and created a contour and I selected the entire top edge or the outside loop here. Right now we're currently in wireframe. I'm going to toggle this over to solids. And just like what we've done before, I'm going to turn off my face here and I'm just going to select this loop so that we're going around clockwise. We'll hit the green check mark, and then inside the tool tab we'll just use the 5/8 flat end mill finish, and I'll just name this 1, 2, 3. This is just going to be a bad example toolpath. We'll end up deleting this here in just a second. But I'll just jump down here to the cut parameters. We will leave this all the same. Stock to leave on walls and floor, 0 and 0. We're going to jump down here into lead in, lead out. We will have that turned on. And then the last thing that we're going to do is we're going to jump down here into the linking parameters. Again, we want to make sure this is registering as absolute, 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 and absolute. Top of stock, since we removed that already with the face mill, if we click on top of stock here, click on that edge, it should be 0. And again, here's the bad example. Here's where you could start to run into some trouble. So if you were using the depth command and say maybe you're just trying to go to this edge, you're trying to get rid of some burrs, maybe there's some flashing left over from first operation, and you were just going to go ahead and type in a value. So we're here at 0, and you're like, okay, I'm going to go down to 30 thousandths below. And I go to negative 0.0312, and you accidentally fat finger this, or you forget to put a 0 here, and we go to 0.312, this is going to be a full 5/16 below the surface of the part. We hit the green check mark. I can clearly see that the toolpath is traveling in the soft jaws and it's running below the top surface of this part. Now, this is very easy to see because we really only have 3 toolpaths in second operation, but start to think and imagine yourself in more advanced parts where maybe you have 10, 20, 30 toolpaths, and all these toolpaths are overlapping, and it's not really easy to see if this toolpath is going to intersect with this soft jaw or any of your work holding components. So you go ahead and you post this out, you look at this and verify, and you go to second up top, you select all these operations here. We click on the verify selected operations, and once again we hit the play button. Everything looks good. I'll turn off stop collisions here. We'll hit the play button and everything looks good, and the toolpath finishes up here. Well, we want to be able to tell if this tool is actually going to collide with this fixture. And the easy way to do this is if we move over here into the Verify tab, we can actually turn on collision checking. So if you turn on collision checking, it's going to be this third icon here in this top row. And you actually want to click on this pull out arrow. It's just going to be right below collision checking, right next to collision. There's just going to be a small little arrow right here. We'll click on collision checking. And you can actually turn on tool versus fixture. So this is going to be a parameter, so whenever the toolpath is running, it'll give you an error report if the tool is going to hit that fixture. So make sure that tool versus fixture is turned on. We'll hit OK. We'll jump back here into the Home tab. And then if I click on Stop Conditions, it's going to be this stop sign right here. We'll click on Stop Conditions. And then we go and hit the drop-down menu here. We can actually tell the program to stop if it's going to hit a collision. So make sure that you have collisions turned on, and then I'll hit the play button. I'll slow this down and we'll rewind it, and this face mill looks pretty good. We're facing that, but again, we accidentally fat fingered that. We went down 5/16 instead of just the 30 thousandths, and the program is actually going to stop and tell us and verify that we are going to have a collision occur. So you can come down here to the bottom right hand corner inside of verify. There's going to be move info, move list, and then there's going to be a report tab. So if you click on report, we can clearly see that there is a tool versus fixture event that is occurring that is preventing this program from finishing. So we can see down here in our playback bar, the program is stopping at this location right here. And again, this is why it's important that we bring in this work holding fixture and we're able to check this. It's just good practice. I know it's a little bit simple, especially when we're just trying to do a simple face mill here on the second operation of this bracket exercise. But as I said, as you start to get into more complex parts, and as you actually start to get into the third revision of the bracket exercise, so bracket exercise P3, you will get pretty close to this work holding assembly or the top face of these soft jaws. And you want to make sure that you're not going to collide with those. So this is just a good double check, especially before you go and post this program and give it out to somebody to run on a machine. So I'm going to back out of here from the verify. I'm just going to select on that contour that I created and make sure that you're only selecting on that contour and that contour only, and we'll go ahead and delete that toolpath from this operation. Now, one last thing that I want to make mention of, especially as you're going through revision management, let's say an event occurs where maybe the length of this part needs to change and you actually need to open up your soft jaws a little bit more. You don't have to bring in a new assembly or create a new assembly for that soft jaw. All you really need to do is click on the components that you need to move. So for example, if I have to click on this component here and I have to move it out in this assembly, when you click on that component and it's highlighted in yellow, you're actually going to open up this solid selections, and this is going to be this little tool window here as well. So inside of this tool tab, we're going to look for the dynamic command. This dynamic command is going to be the exact same dynamic command that you were using when we merged in this entire work holding assembly earlier. So if you click on this dynamic command, you can go ahead and click on the origin or the gnomon or any one of these edges and then move this part out as needed, and you can get full flexibility and compatibility to move this around if you have any revision changes happen. However, I am not going to move this component. I'm going to hit X here. I'm going to return it back to its original location. If you do end up moving this using the dynamic command, it may change the color of your components. A really easy way to clear those colors is if you right click on that component, and from the drop down menu here, we're actually going to select on this icon. It's going to be the fourth icon on the second row here. It's going to be a column of colors. It's going to be red, blue, and yellow, and it's going to move over here to a column of no colors. So if you click on clear colors here, it's going to remove all those colors. Now, again, one last thing, if you have to move this around, say for example, the part grows in height and you need to move your entire work holding assembly here, all you need to do is move back over here to the levels tab. And inside the levels tab, we're just going to right click on this entire work holding level here. So we have 7 entities linked to that level. We'll right click on the work holding level right there. And from the drop down menu, you're just going to find select all entities. So if you click on select all entities, it's going to highlight everything in yellow. And we can go ahead and access this solid selection, this tool tab, and inside the tool tab, we're going to find that dynamic selection once again. So if you click on dynamic, you can access this entire work holding assembly and move it all in one go as well. So for example, if you had to move this down, we can go ahead and move back over here into the view tab. We can change this back over to translucency. And then if I have to, for instance, move this entire assembly down from this face, we'll click on the bottom face, or in this instance, the top face from first operation. So I'll click on this bottom face and second operation, and we just have to move this down in Z. We'll just go ahead and select on this blue stem here, and you can move this incrementally using this ruler on the left-hand side, or you can type in whatever value, or if you bring in P2 or P3 and you have to relink it to that edge, you'll just relink it to whatever new edge. And again, once you're done with that, you'll hit the green check mark. For me, I'm going to hit escape because I'm not going to change this. We'll hit the green check mark to complete this. And if I don't want my entire work holding assembly to be shown here in red, all you need to do is right click on one of the components here, and then from the drop down menu, you can go ahead and clear the colors once again. That'll get rid of all the colors. And I'll just change this back or turn off my translucency so that I'm no longer looking through the part. I don't have any transparency. And this is going to complete second operation for the bracket exercise P1. So you can go ahead and save that. And I just want to make mention of all these little details that went into this one single toolpath. We ended up creating a stock model that linked first operation into second operation. And we also brought in this entire work holding assembly with these soft jaws so that we know exactly where our fixtures are. And again, it might be a little bit of overkill for this one single toolpath, but as you started getting into 5-axis programming, whether it be indexing or simultaneous programming, you're really going to want to have all these components constructed inside of your MasterCam session so that you know exactly where the toolpaths are going to travel and what they need to avoid. So thanks for watching, and we'll go ahead and catch you in the next one. Bye.